A very warm welcome and good morning, good afternoon, good evening to our audience joining us from the various parts of the globe. Welcome to this TCS Mastercraft event on generative AI powered enterprise modernization, future proofing your IT landscape. My name is Divya Bhatla, and I'm the marketing lead for TCS Mastercraft and your host for today's event. In the ever-evolving landscape of technology and business, we often find ourselves on the cusp of a remarkable transformation. The emergence of Gen AI is reshaping the core foundations of how we envision, adapt, and traverse the business landscape and redefine our approach to enterprise modernization in ways we could only have imagined. So Gen AI is not just a buzzword alone. It's about effective utilization of the AI capabilities to make enterprises smarter, more agile, scalable, and efficient in a dynamic business landscape. So generative AI is shaping the exciting possibilities of the future of enterprises. And our aim at TCS is not to adapt the change, but to lead and shape the change for the future of enterprises. So in today's event, we have an illustrious panel comprising of some eminent speakers from the industry. These panelists have a deep understanding of matters pertaining to Gen AI-led IT transformation and expertise in enterprise modernization. So these subject matter experts will bring their perspective regarding the larger expectations on adapting generative AI for future-proofing the IT landscape and its implications on the global markets. So let's just get started on the session of this panel discussion. This panel discussion is moderated by my colleague, Dr. Padli Nathan, whom we formally call as Padli. It's my privilege to introduce Padli, who has more than 35 years of industry experience, and he has been leading enterprise scale transformation of core applications to align with their digital journey, including cloud-based architectures. So as the head of core modernization and AI cloud engineering services at TCS, he is building platform capabilities for large enterprise-grade mainframe transformation engagements. This consists of strategies for nurturing the core, reusing the core, and actually replacing the core. He has been a mentor, a SteerCo member, an architecture board member of transformation programs. Padli has great experience leading initiatives specific to enterprise modernization services, consisting of application modernization, architecture modernization, IBM Z, and workplace modernization streams. With this, I would like to hand this over to you, Padli, and request you to please moderate and take this session forward. Thank you.
Right, thank you. Thank you, Divya. Good morning, good evening, good afternoon, wherever you are. It's a privilege actually to moderate this session along with our industry-leading expertise on core modernization. Enterprise modernization, now every CEO or every C-level exec is actually pushing their enterprises to leverage digital technologies. And this is primarily towards growth and also to improve the stakeholder experience across. And we are actually receiving queries from enterprises across domains. And business agility is the key driver. And businesses actually want to transform, integrate better with their ecosystem partners, provide a differentiated experience to their stakeholders. And obviously, also the skills and costs of some of the older technologies are the key drivers for this enterprise modernization initiatives. And another key factor that we see is cloud adoption. Many enterprises are actually moving away from DC to cloud. They do not want to manage their IT estate. Instead, they all want to use everything as a service. And obviously, with the multiple clouds coming into being, and also some would like to have few of their business processes on-premise, hybrid cloud is actually becoming order of the day. And so enterprise modernization is a big theme today. And obviously, modernization and automation are inseparable. And they are conjoined, in fact. Most enterprises are also planning for incremental modernization. That means actually the complexity just grows exponentially. And automation is very key, right from analysis all the way up to implementation. And generative AI is the talk of the day. Every C-level exec, as they talk about modernization, they also want to know the role of Gen AI in this journey, whether actually like it is code remediation, documentation, test harness improvements. So it is actually like, it is E to the E. I mean, like it is much more actually, the number of queries that we receive around modernization and Gen AI and the intent to do POCs, POTs around this technology, it is phenomenal actually. In the last 2 quarters, there is not a C-level exec meeting without talking about Gen AI for at least 30 minutes, 40 minutes. We are conducting workshops, 2-hour, 3-hour workshops to many of our customers. And post ChatGPT launch, I mean, like everyone is now talking about LLM. LLMs are there for a long time, but then now there is an increased interest in code LLM and also using code LLM for modernization. So today, we actually have a set of experts with us. I am extremely privileged and happy to introduce Dr. Ira Baxter, CEO of Semantic Designs. I met him first in 2011 during his participation in Tactics. Baxter has been associated with computing since 1966. Yes, I mean 1966. Okay, I mean I was born in 65. When I was a 1-year-old, Dr. Baxter has already been into computing. And I don't want to talk about Gen Z and the millennials. So he implemented the first microcomputer time-sharing systems in 1970s, and then started Software Dynamics, designed compilers. And also, post his PhD in the University of California, Irvine, he spent several years in Schlumberger working on CM5 supercomputers. In 95, Dr. Baxter founded Semantic Design, focusing on modernization tools that will actually radically improve the economics of software enhancement. The cost per line of conversion, cost per line of code, he has actually made tremendous efforts in bringing them down. He also provides consulting to Fortune 100 companies. And also Dr. Baxter is a principal architect of Semantic Designs, Design Maintenance System, DMS. He's a principal designer, compiler implementer of Parlance, and he is also into parallel programming language, and he is a principal engineer on CloudDR. So I have been actually pushing we are trying POCs and using semantic designs in multiple of our projects for actually modernizing legacy applications. We also have Ramkrishna Vem, Ramki. He is the head of our BFSI mainframe modernization strategic initiative. It is a niche stream actually that is focusing on core modernization and has been associated with the modernization of core applications for the last 24 plus years. And he has been part of extremely large, complex modernization programs. And he has grown along with modernization in TCS. And he has been involved in many consulting and delivery engagement over the last 20 years. and he is playing a very leading role around generative AI initiatives for the entire BFSI. And I also have Dr. Tamil, who is a good friend of mine over the last 30 years, right from our research days. He is the CTO of Mastercraft, and he's also head of Transform Plus suite of Mastercraft. Dr. Tamil is actually involved in software engineering right over the last 24 years. And he is into language processing, software engineering specific to compiler-based technologies. And he is deeply involved in tools for application analysis, application transformation, application refactoring, and also for code generation for more than 25 years. He's a key automation strategist behind many of our successful engagements. And he is also, spearheading initiatives. He's leading the change in using GenAI as part of the Transformation Plus toolset itself in accelerating the conversion process, refactoring process, as well as the understanding process. So this is the elite panel, who will be actually providing their insights on this topic. I will actually go to Dr. Baster first. Dr. Ira, what is your observation on the trends of core systems modernization? You have been in this space for a long time. And also, how is semantic designs helping enterprises across the globe in their modernization journey?
Sure. Okay. So I'm Ira Baxter. Okay. I'm really pleased to be invited to this panel. It's quite an honor. I appreciate that. Thank you very much. As I said, I've been building software engineering tools, automated tools for about 50 years. Okay. And in fact, if you go back to 1983, you'll discover in IEEE software, probably the first paper on software, automated software migrations written by myself. Okay. Our principal engine is an engine called DMS. Okay. This is a piece of, it's a combination of what used to be AI technology, program transformations, and compiler technology. And we've been investing in it for almost 30 years now. Okay. And it's been very effective at helping us carry out lots of tasks. We do more than just enterprise modernization. Okay. We operate on software analysis, software abstraction. We operate in the embedded space. We operate in enterprise space. DMS is very flexible in terms of what we can do. Some examples, okay, we do COBOL to Java or C# migrations in a variety of modern dialects of COBOL. Okay, we've done migration of embedded factory systems, okay, to run Dow Chemical for 800 different factories. We've done our large-scale API replacement, okay, for avionics flight software for Boeing. All right, and we've done abstraction recovery from 18,000 programs that look at car engine control units to figure out what they do. And these are all done with the same engine, okay, which and that's possible because of its foundation. We don't have time to go into those foundations at the moment. Okay, we can talk about we can talk about what enterprises are interested in from us. So when we talk about enterprise modernization, okay, we have clients and they have kind of two major interests at this point. And that will probably change over time, but this is a snapshot. The first one is what I would call push. Okay, push means get me to anywhere but here. Okay, and largely that's driven by the fact that they're running on some legacy hardware, legacy languages, legacy databases, legacy controls, legacy screens, legacy security, legacy everything. Okay, and while those platforms have been very effective in the past, okay, they're getting expensive. Okay, the legacy technologies don't perform as well. You can't find people to maintain them. Okay, it's hard to go forward in the future. They don't integrate with the other client systems. So they have all sorts of trouble. They're very successful, but they're also problematic in the sense they can't evolve it, right? So if you can get out of those systems, okay, you get significant benefits. Okay, you can lower your costs for your legacy hardware and the legacy software and licenses. You can access a better talent pool. You can get a wide variety of people who know Java and C#. They're easier to hire. They'll last longer. They're not retiring. Okay, you get better development tools that makes your people more productive. Okay, and you get better integration. Okay, with other systems. It's a win all the way around if you simply leave the legacy technology behind, without regardless to where you go. Right? Now, in the experience that we have with our clients, okay, we do the migrations that we do. We get 99.9% automated migration. Okay, and the question is, why don't you do 1%? The answer is because the last 1% is not worth doing with automation. Is you just do it by hand and just finish it off. All right, and that's the way we handle it. Okay, and that's all doable. Okay, at reasonable cost. All right, the kind of machinery using the program transformations is the core to our technology. Okay, it gives us highly reliable transformations. Whatever your system did before we migrated it, it will do that afterwards. So you don't lose any functionality. There's no worries about did you drop something or did you break it. And that has to do with the fact that the transformation rules that we use, things that drive TMS, are semantic preserving things. They say if you see this piece of syntax with a certain semantics, replace it by another piece of syntax with the same semantics. And that means the translation is reliable. You get good maintainability, okay, in the sense that you get procedural code that is reasonably maintainable if you ignore the howls of the programmers that say that's not object-oriented stuff. Okay, the reason it's not object-oriented stuff is because nobody did an object-oriented analysis anywhere and they're not willing to pay for it. But you do get good procedural code. It is maintainable and you can go forward in the future just fine with that, right? There's using this kind of technology, there's a very high probability, okay, that you meet your schedule. Okay, and that's important when the clients have an endpoint. They got a lease date they have to get off. They've got a transition window in which they have to make the conversion from the old software to the new window. You've got to hit it. You get a reliable schedule by using the automation effective way. And the bigger the application, the larger the payoff. Okay, because the machinery can convert millions of lines of code just as well as it can hundreds of thousands of lines of code. Right, so it's a big win. I assume that the TCS Mastercraft tools do something similar, but I'll let the other speakers address that on their own. All right, so one of the pushes, one of the client interest on one front is the push. We just talked about that. The other one is clients are interested in the target. This is the push behind, well, the pull, okay, to get to clouds and things like that. Most of our clients come to us starting off what we call, gee, I want to get to the fairy castle on the hill. I want to be in the cloud. I want to be dynamically scalable. I want to have my architecture re-engineered. I want to have full object-oriented. I want full microservices everywhere. Okay, we call this the fairy castle on the hill because they're basically asking for every possible technology feature they could get. And we understand that. Everybody wants a pony. There's no question about that. Okay, there's a question of can you get there easily? That's a very hard problem because those kinds of things require massive amounts of re-engineering. Okay, and the tools are generally not strong enough to do that kind of thing in one step. So what we typically offer to our clients is a two-phase process, one of which gets them out of their legacy technology, and the second phase which tries to bring them into more modern technologies like microservices, things of that nature. Right? Now, when they come to us, okay, you try and do these sorts of things by hand, you discover it's an extremely expensive process. It takes a very long time. You don't know when you're finished, and you never know if you can actually replace the old system accurately. That's hard. Okay. People argue they can do all this with manual rewrites. Okay. And forgive me if I laugh when I hear that. Okay. Most of the people who try that fail disastrously. Okay. And I will say that some fraction of the clients who come to us have done that failure disastrously, and that's why they're willing to consider automation. The good news is that with this kind of automation, you can replace all that legacy technology. Okay, you can bring in SQL databases, GUIs, web interfaces, modern schedulers, scripting in Java or C#. Okay, whatever security protocols you need, you can do all that with the automation. Right. So that covers the sort of the push side. All right. Let me speak a little bit to the pull side. Okay, and then I'll stop. So the pull side is moving to the cloud. Okay, this seems to be a popular idea. Okay, but fundamentally because it avoids the on-prem hardware software management costs. Now, to do that, you have to get rid of your legacy technology because clouds don't run legacy mainframes very well. Right? So people do all that. Okay, and one of the really big wins for moving to the cloud, okay, in my opinion, okay, is the implicit offer that legacy data will be available so that this system can integrate better with the rest of your business, and that makes the business more efficient. For me, that seems to be one of the really enormous wins. It's integration, integration, integration. That's the win. Surprisingly enough, we get requests for cloud-based scaling, dynamic scaling, because that's the buzzword. Everybody says, gee, my application be scalable. I say, how many users do you have? And they say, 2,600. Okay, is it growing? No. Why do you need to scale? Okay, if you can deal with 2,600, you're fine. So when you move to the cloud in those kinds of cases, you don't need dynamic scaling. You need adequate scaling. And you can often organize that without doing anything really spectacular. Right? So many don't really want this. So clients are interested in two fronts: leaving their legacy systems, leaving the technology behind, and moving towards the cloud. That's the big push.
Thanks a lot. Thanks a lot, Dr. Ira Baxter. Next one to you, Ramki. I mean, are you also seeing a similar trend in BFSI organizations when they actually attempt their modernization? And how is the spread actually? How many of them are actually into this journey? And any thoughts around that?
Thank you, Bodley. First of all, thanks for the invitation. Glad to be here. Hello, everyone. As you rightly called out partly in the beginning and supported very well by Dr. Ira, BFSI is not quite different from what you said in terms of the context. But let me anyway spend a minute to give the context why we are here and what is this need for modernization. So most of these mid-sized to large banks or insurers or even capital market firms, you can see their technology investments go way back into 60s, the date that that Rita talked about. And they've built these mission critical systems, not as individual applications back then. It was more of banks in a box or an insurance firm in a box. That is how the expensive the storage and the computing power back then was. And over a period, it just kept growing in complexity. And with the advent of internet at the turn of the century, then the mobile apps, and then open source, and now cloud computing, all these have made sure that the digital technology adoption has grown significantly in the banks and insurance firms. At the same time, the skills also started moving off these legacy platforms, whether it is IBM Z's, IBM I's, RPGs, and COBOLs, into the latest fancy technologies, right? And that is good. What has happened in this way is the skills are slowly moved from legacy to the new technologies. The integration continued to happen in a big way. So it is a spaghetti everybody keeps asking, right? When you look at the old applications, they're not retired, they're not modernized to the scale that they exist today. But the plethora of applications on the target, the systems of engagement, for example, the systems of analytics or insights, they continue to grow in number. And all these back and forth communications have really increased the complexity. That's the second part. What also incidentally happens is because of these mobile apps and the real-time nature of everything. Now, I just made a transaction from an ATM withdrawal. I need the transaction immediately, my balances. So inquiring. When you used to get in batch in early 2000s, for example, 1 million transaction used to be great. Today, a same bank might be doing 1 billion transaction. Not necessarily the similar growth has happened either in their card base or account base or customer base, not in the same proportion. So given these factors, a lot of the customers have gone on a modernization path for sure. And wherever the business case is strongly founded by either M&A or a divestiture, or for example, anything like the vendor risks. So for example, you're talking about either IDMS, ADSO, where the support for skills is absolutely minimal compared to your standard IBM stack. Those are the cases where a lot of customers have already done certain modernization, they've seen success. The other aspect is wherever there is the disrupted innovators or the fintechs or insurtechs who are just taking the market by storm. It could be the payments, and today you hear about this real-time payments all over the world. And we have seen the success in India and a few other markets. So these are the kind of business-driven or business-led transformations that are also giving impetus to the modernization that we are seeing when it comes to the core systems. But let me tell you this. I talked specifically about mid-size and large enterprises who have billions of lines of code. Most of these Wall Street firms, we're talking about 250 million lines of code of all languages is the bare minimum, standard, you can say. Now, nobody's really talking about a complete exit. right? Someone in about their weight, they're not looking at a complete exit, but then it is driven by those factors. It is driven by those requirements or objectives. Maybe I have a portfolio that needs to be more agile. Maybe I have a certain functionality that needs to go global, right? So those are the things. And payments is a classic example, whether it is cross-border or cross-currency or instant payments or card payments. The real-time settlement, whether it comes from a capital markets firm or from a credit card company, right? Those are the areas where real-time settlement, where you used to do T+3, now T+2, and today we are talking about T+1 kind of settlement. And India is already talking about almost real-time settlement on the same day. So those are the ones that are really requiring some kind of a modernization. Now, we all know it's a very complex subject, where code conversion, for example, from COBOL to, let us say, Java is just one piece in the bigger puzzle. I cannot put a percentage, it could be 10, 20, but then the whole discipline with respect to assurance, the discipline with respect to the quality engineering, for example, the program governance, the entire developer or operations environment, all of that goes in hand. So when you talk about modernization, all of these moving parts have to be addressed. And that is where the efficiency of any conversion tool, or whether it is GenAI, whether it is compiler parser based, that really matters. And the real modernization from a R factor lane, right? Everybody talks about the 6R or 5R lane. Traditionally, we have seen the smaller insurers or banks going in the rehost or refactor way. Yes, the rewrite is definitely complex, and that is where you need to understand what the business is doing, but don't exactly replicate it in the target set. But that's the place where Dr. Ira also had a fair point, that nobody has unlimited budgets, right? You will not get millions to be able to do a clean rewrite in the target tech stack. So it's always context-based. A particular customer needs to exit by so-and-so date for whatever reasons. A particular customer needs agility for ABC reasons, right? That is where you will make sure you're putting the right R path. And that's where we come into play in terms of giving that right path for modernization for the right reasons. And it is always a progressive modernization for these large customers. And nobody's really looking at a big bang modernization.
Thanks, Ramki. Dr. Baxter pointed out the pull and push scenarios. And Ramki also insisted that it is not just code conversion. There are multiple other things that need to be taken care from a modernization perspective. And also that means like automation is not just around code conversion. So automation being a very important element of modernization, and as head of Mastercraft Transform Plus, what is new actually in Mastercraft in terms of the product set and features, and also how do you see, GenAI playing a very vital role in the scheme of things that you lead?
Yeah, thank you, Padli. Thank you very much. Happy to be here. Yeah, as Ramki and Dr. Ira talked about, today the expectations of the modernization is much more than the code conversion. Before I talk about what type of automation that we are bringing in, just let me take a minute to introduce what is Mastercraft Transform Plus, and then I will talk about what are the new things that we are that are coming up. So Mastercraft is in the legacy modernization space, and bring in automation tools for code conversion, code analysis, documentation, business rule extraction, data migration, and the various aspects of modernization where we have automation capability in Mastercraft today. But today, when we talk about modernization, the expectations on the target application is much more than what it was some years ago. So people are expecting the applications generated or converted from legacy should not carry the legacy characteristic. Rather, it should leverage or exploit the technologies that are available right now. For example, inbuilt intelligence, inbuilt chatbot, and much more than that. So from an automation perspective, we are not just looking at a conversion or take a like-to-like conversion, rather understand the type of application, whether it is transactional, analytical, reporting, what type of application it is about, and then accordingly build a conversion toolset, accordingly generate those specifications and regenerate. And doing that, we also bring in the inbuilt intelligence capability, which has self-learning and other things as well in the generated application. So this is one area. So there are three important areas that I will go through. This is the first one. Second one, when we talk about modernization, there are different pieces together. It's not just one piece alone. When I say different pieces, it starts with understanding the legacy, generate specifications, and then use the specifications to regenerate the code, and not just regenerate what is available as services in the open world, pick up those services, reuse them. So there are much more than that in it. So what we are doing in Mastercraft right now is bringing in the integrated capabilities, starting from a decision making of whatever the 7R decision making, all the way up to the CI/CD and deploy into the target, and exploiting or leveraging the target technologies and the capabilities, bringing in an end-to-end capability and connected together with a complete traceability. So this is another important area that we are bringing in automation to the maximum level. And third one, of course, the generative AI is coming in. But even before the generative AI, the machine learning, the natural language processing, NLP, and the neural network, it's all been there for quite some time. So we are leveraging those capabilities and then adding additional automation capability on top of what we have with the traditional algorithmic way of doing the things. A simple example, how a technical business can be combined in an automated way. Today, it is pretty much a manual subject matter knowledge is required, but how a business and the technical things can be combined using a trained neural network or leveraging the NLP techniques, how we can build that type of feature and the capability is another area that we are working on. So these are some of the new areas or new topics that we are working on. Now coming back to the next question partly on the generative AI. Of course, generative AI is a very, very important element, and it's definitely is applicable in the modernization space. But from my point of view, it is not going to replace the existing capabilities or the process. Rather, it is going to augment. So there are traditional challenges, traditional issues are there, where subject matter experts are required when we execute the modernization. But now when we talk about generative AI, all those subject matter experts' knowledge can be built into the generative AI, and that can augment when we actually do this transformation. In that aspect, whether it is reverse engineering, or whether it is code generation, or whether it is the code conversion, or even decision making to decide what way that I should go, that we have started looking at adopting generative AI in terms of training the model with our contextual knowledge, training the model with the code language constructs, and then see how automatically we can generate not just technical specification, but also functional specification. And with the functional specification, how I can regenerate the target applications. And not only that, within Mastercraft, we are also building the Gen AI workbench. So what it means is when we talk about this modernization with Gen AI, it's not just one model. there are multiple models, multiple tasks that we are going to create as part of this. So we want to have a complete orchestration engine on top of it, where it provisions multiple models and then execute the various tasks and then finally achieve the end-to-end modernization is what that we are looking at on top of the existing automation capability what we have. So in summary, yes, we are going to build on our strength, what we have traditionally using our compiler technologies and other things. Also adapt the generative AI capabilities to augment the process further and then close to near 100% automation into the overall modernization journey. That's the summary for both the questions.
Thank you, Dr. Tamil, and it's very interesting. I mean, like, so right from not just code conversion, I mean, like all the way from analysis, requirements gathering in case of reverse engineering and forward engineering, there are actually like new features that are expected to be available as part of Mastercraft Transform Plus. Great news, Tamil. I will move to Ramki. Having heard Dr. Tamil, Ramki, I mean, like you are also looking at a larger gamut of GenAI capabilities. Along with Mastercraft, you are also looking at the market specifically. What are your plans actually specific to GenAI for modernization? And what are the typical challenges that you foresee? Because there is IP, I mean, like that is there with the customer, and there are hundreds of aspects related to IP, because that is the one that is differentiating the customer from the rest. So how do you see GenAI? How are you actually planning to leverage in case of the BFSI mainframe modernization initiatives?
Sure, Patley. So just the way it was said at the panel discussion earlier, right? You cannot have a discussion with an executive without GenAI coming into play for 30, 45 minutes. In a BFSI context, it's the same case for the security and privacy by design. So when we talk about any of these, LLMs or generative AI, I think that is one of the top questions. How are you addressing in your any of the examples or any of the pilots that you've done? That is the first question everybody asks. But let's again step back and see what is the context for that, right? As Tamil said earlier, AI and machine learning have been around for a while. Now, whether it is the deep learning techniques, the parsers, the compiler page, I think they've all been around, and we've seen certain percentage of automation or success in those conversions for sure. And the code conversion in terms of one-to-one, that kind of bots existed earlier, right? But when you look at the generative AI and the foundation models that are coming from everywhere, whether it is OpenAI, Copilot, or GitHub, or let's say IBM Watsonx, that's the latest new kid on the block, right? And it all started with, of course, the ChatGPT-4. So each of these models, their training or pre-trained model is definitely not going to be sufficient to give you the best results. And that is where you need access to the customer's environment, both in terms of the programming language code, which is running into millions of lines in each customer, and also at times the actual data, which is the end customer's data, right? Whether it is PIA, sensitive, or otherwise. That is where we are seeing a lot of apprehensions, right? But at just the beginning of the time, I think give it 2, 3, 5 years, things can go much smoother, because we definitely believe generative AI for this particular discipline has great potential, the benefits outweighing the risks. But at the same time, you need to look at, if you really equate this to the public cloud adoption in BFSI sector, BFSI was one of the latest entrants in terms of adopting in a big scale the public cloud, whereas every other sector probably had taken it up in quite an early fashion. So even today, if you look at the transactional systems or the core systems, there are very few instances where somebody has gone really public in terms of the cloud. It is for the same reason, whether it is security, whether it is the reliability, whether it is the availability, entire qualities of service that come with your existing systems of record. And at the same time, the point that you mentioned, IP rights. If a model does give me what I need, who owns the IP? Which part of the model has used what part of data point, right? So that ability to give incidents, right? And say this is from my public open source model, this is from my trained on your data. So that kind of an information is extremely important. And end of the day, to begin with, I think most banks and insurers, they're comfortable in acquiring these technologies for an on-premise kind of deployment to begin with. And all sorts of experimentation is definitely already happening, whether it is, talking about the latest one, Watson X, or even Mastercraft, we're talking to some customers. Right? These are the initial experimentations. So on-premise deployment probably is the way to go. But eventually, it will become a trade-off between the cost that you are ready to spend on this versus the value in terms of productivity enablement or any other acceleration it is going to bring. And it's going to be an exciting journey. Today, we may not be able to exactly quantify, what is the cost, what is that value. But as a company, I think we're all believing that there is great potential for this particular technology, and let us see how it unfolds.
Thanks, Ramki. Thank you very much. And moving on to Dr. Baxter, you have actually heard Dr. Tamil and Ramki talking about what is being attempted specific to GenAI on a broader theme. I mean, having been the author, and you are also improving DMS day by day, addressing all sorts of languages, extreme end from an automation perspective, 99.99% for many languages, Dr. Baxter. In that case, what are the core research and innovation themes that you would like to bet specific to automation of modernization? Because one is the actual code conversion, and then comes the performance, and also the other layers like security and all that. So what is the R&D theme that you are planning to bet big for the future?
So that's a great question, okay? Because there's a lot of interesting technologies out there. I'm an engineer. I want to do things that work, are effective, okay, and don't kill me. Don't kill me trying to build them, right? So I'm going to talk about a wide variety of topics, sort of shall we? I make the first point, okay, is the technology which is not widely used, which surprises me completely, is what we use. We use something called source-to-source program source-to-source program transformations. These are essentially explicit statements of fact that say, if you see a code construct that looks like this, it's equivalent to a code construct that looks like that. That seems like a really simple idea, and yet it's incredibly powerful. Okay, in particular, it's essentially knowledge capture. Okay, you can reuse code. People have been trying that for decades. It's better to reuse knowledge. Okay, that's the real big win. Okay, and source-to-source program transformation allow you to encode knowledge in small bits and in large quantities, and that's what makes the projects effective. Now, for what it's worth, the source-to-source program technology was considered as AI in the 80s and the 90s when I was a graduate student. Okay, nobody talks about them anymore, okay, except for us. That surprises me. Okay, and so they're not labeled as AI or not, okay, but it really doesn't make any difference. From the engineering point of view, they are effective, they work, and I'm surprised I don't see more. Okay. All right, there are complications having to do, with these systems, having to do with the wide variety of information, okay, and technologies they use, okay, multiple languages, databases, distributed systems, multiple machines, okay, and we're starting to see all that stuff, and you need ways to deal with all that, okay. They're all different kinds of, to deal with each one of those aspects, you have to deal with knowledge, you have to capture something about them, okay, and you have to have a way to do that that's regular and organized, and that's why the source transformations are so powerful. One of the other interesting pushes is, how do we transform legacy systems from whatever the legacy architecture is into a modern architecture, say, including microservices? It turns out that you can do that. Okay, it's more transformations. So the way we see the process is you can do transformations to move you out of your legacy system into a modern technology that might not be architected beautifully, and then you could do more transformations on top of that to reshape that architecture to do what we call an architecture shift, to bring it to modern technologies. Okay, I think that's a direction to go. I think we'll see more of it in the future. Tools as we have them anyway, I don't know about Mastergraph, okay, aren't capable of doing that by themselves easily. And the clients often say, I'm happy, just get out of where I am and we'll think about the other stuff in the future. But there's going to be a big push in that direction. Okay, these are going to be tools that are have lots more knowledge because they have to deal with lots more stuff like architectural shift. You have to move code around in global ways, and that requires very complex mechanisms and knowledge to do it. Right? Obviously, the hot topic of the panel is generative AI. Okay, using large language models. Okay, I will say that I'm a skeptic. Okay, there's lots of interest. Okay, but there's lots of interest in all sorts of things that people declare to be magic. When people don't understand how a technology works, okay, they just assume it can do everything. It's not true. Okay, the generative AI guys are really good at producing examples that look really good. And the question is, are they really good? All right, and you discover in many cases that people say, well, yeah, there's a hallucination in that thing. Okay, which means it's almost right, but it's wrong in a really incredible way. Right, and that's going to make it very hard to use these kinds of tools for modernization purposes. Okay, when I'm facing a system with millions of lines of code, I can't have the energy to stop and look at every 100 lines of code and ask, what does that do? I can't do it. I don't have the energy as a human being. So I have to have a tool that does that. Okay, well, I can use automated tools like the program transformation we talked about. That transforms things right, preserves the properties. You don't have to look at it. It's guaranteed to work if we got our transformation. If you use generative AI to say, let's regenerate that piece of code, two things go wrong. One is, now I have a human being in the loop. That largely negates the advantage of automation because I now have a person looking at each piece of code in the system, and there's your economic cost go high. Second is, even if that guy's really good, really smart, okay, and he says, here's the right context question, here's the right prompt, okay, and he uses that to kind of generate a replacement piece of code. You don't know if that code's reliable, which means now you have a debugging problem. Okay, now if I convert millions of lines of code, and every 100 lines I add a bug or two because of my technology, I have now an incredible debugging problem. Okay, so it's not clear to me that generative AI in its present form is actually going to be really effective for this kind of modernization. Will it be effective in helping people understand code? Yeah, probably, because if you come in sort of close to what it does, people kind of figure out the rest of it. So it might be useful to help people understand things in a sense, right? The key problem is what's called a context. Okay, current generative AI schemes, okay, use the LLMs, okay, use what's called a context, and they typically allow 1,000 tokens. Well, if we work that out, that's about 50 lines of code. I've got millions. Okay, they're all context, and if I leave them out, I don't know that my transformation might be right. ChatGPT 5 that's coming out of OpenAI, they claim to have 100,000 tokens. Okay, well, that's good for 3,000 lines. It's a little bigger than a COBOL module. That might actually be useful. Okay, time remains. We haven't had a chance to experiment with this, so we simply don't know. But the bottom line, okay, is that LLMs aren't reasoning engines. They don't reason. They are not semantically accurate in the way they interpret their results. They are merely probability predictive of what the next word that should come out is, right? So you just don't, there's no guarantee with generative AI that you get a correct answer. Only you get an answer that might be close to the truth, right? So that's the big problem, right? All right. Second issue is to do a full translation, they have to understand what the translation works like. I put COBOL in, I get Java out. To do that, you have to train it on COBOL to Java examples. Where do those come from? Somebody has to build a database of those. Large-scale migrations are not lying around in the web world that the LLMs are trying to mine, okay, in order to get their knowledge, okay? And so the question is, what are they getting their example translations from? Right? Because they can't make them up. They can only offer them if they're in the data they analyze. So I think there's other uses of AI that are probably a bit better than the generative AI, okay? And that's what I call symbolic AI. Symbolic AI says we should be able to represent knowledge, okay, about our system in abstract ways, and we should reason about that knowledge using mechanical principles which are semantically well-founded. If you do that, whatever conclusion you draw, interpretation, transformation, performance analysis, your answers are semantically correct. Okay, and that's the leverage we need. And what we have these days, we didn't have 20 years ago, is enormous amounts of computing that we have available to us that we can bring to bear in doing the symbolic reasoning. And I think that's going to be the really big win over the next 10 years. A help for engineers trying to do migrations or even working with their system day to day, okay, is to sort of harness this kind of thing for deep semantic analysis. Help me understand what my code is doing so I can make changes to it in a reliable way. I think in terms of not the translation, not the migration itself, but in terms of living with the result, that's going to be extremely important, because what you want to do is you want to leverage the team that have to develop the software, not the team that's modernizing. You're not trying to optimize those guys, just trying to use them. I think there's two very other specific places where we're going to see technologies that are interesting. One of them is automated generation of regression tests. Okay, when I move a big system, I want to know the new system does the same thing as the old one. Okay, we tell our clients that our transformations are highly reliable, and they go like, yeah, we don't believe you because it's our company that dies if you're wrong. Okay, and that's a fair complaint. So they have to run regression tests. And they don't have any regression tests. That's largely what we see. So this is a big gap in the modernization marketplace. How do I validate that my new system covers all the features of the old system? Where do I get these test forms? I believe that you can use symbolic AI, okay, to actually reason about how to extract those kinds of tests and automatically generate them. And now you can imagine a world in which a modernization process is extract regression tests from the legacy systems, migrate the legacy system over, run the regression tests against the new system, and validate that it works. And now everybody's very happy because they're convinced it works. I think that'll be an enormous win. Okay, last one is sort of large-scale interactive refactoring tools. Say once you've modified, once you've enhanced your system, okay, you have to live with it over time. Okay, if you're going to make changes to code, especially architectural changes, you want incremental automated help, and that's where factoring tools come in. I think there's a lot of technologies out there that can be brought to bear. Okay, the good news is, people are working on it, and the not so good news is it's going to be another decade before they start to show up and sort of like really seriously big and available to current clients, okay, in an effective way. That's the hard part about technology. Okay, the part that you have running is really cool. Okay, and you're dissatisfied because there's other parts of technology you really love to have and don't have yet. Life goes on.
Thanks a lot, Dr. Baxter. That's very provocative. And then administering symbolic AI and also a set of things as counterintuitively to Gen AI principles. Great argument, Dr. Baxter. And that actually brings us to the question and answers. There are a few questions in the QA box. The first one is there any tool in place to migrate from IDMS, assembler, and COBOL code base, not line by line, but should be more of functional wise with optimized design. That's what Dr. Baxter was actually describing. Today, there are actually line by line conversion tools, Vallavan. There are not many tools which can actually abstract and then do the optimized design. The next question is from Amit Arora. This is to Ramki. In his experience, which modernized databases are being leveraged for transformation initiatives? What modern databases are being leveraged for the transformation initiatives?
Yeah, I think if you look at it from both SQL and NoSQL, largely whenever it is going to a cloud or a hybrid cloud kind of a scenario, we've seen both the Postgre as well as MongoDB kind of technologies being leveraged. For some smaller workloads, some specific patterns, there is a mention of Couchbase and Cassandra, but then largely it is these two that I mentioned, both Postgre and MongoDB.
Okay. Thanks, Ramki. And we have two questions from Dayal. The first one is, both of them are to Dr. Baxter. If you have achieved 99.9% automation, where do you think Gen AI will be of help in your endeavors? Is it to widen the gamut or improve efficiency? Dr. Baxter has prescribed symbolic AI and also gave a large set of examples, Dayal. But then there is one more question from Dayal. If we attempt to keep eliminating the degree of hallucination, would at some point the GenAI-driven software engineering be the same as an efficient tool that currently exists today? That's to you, Dr. Baxter.
Yeah, so where will GenAI help? Okay, so the problem with GenAI, as I say, is ultimately what it knows is based upon what it's seen, and there's no guarantee that what it's seen that's seen enough to answer your question. And they also tend to hallucinate. Let's ask a question: why does Google work? Google works because a question that you enter, you don't have to get the answer right. All it has to be is sort of okay, and you're good. Look for irons available on the internet, and you get back a list of places that have irons. That's a fine answer. Okay. So where can GenAI be used? If you try to use it to be the core of the translation mechanism, you have to worry about the hallucination contaminating everything. And there's no way to make that go away because it can't possibly know enough and it doesn't reason about the software. All right. Where can you use it? You can use it where the answer isn't quite so critical, and that's the understanding step. So a place that we have to go to when we build our modernization tools, we have to write a lot of these source-to-source transformations. So there's a knowledge capture step, okay, that we do before we actually apply the modernization tool to the problem. All right, and for that step, we need to understand, so how should things be translated? What are examples? The extent that generative AI can give us examples of things, we can say, look, we know those examples might not be exactly right, but if they're indicative, we can fix them. We can debug the rules that we build, okay, the generative AI might propose to us, okay, and that's a good use. So I think that might actually be fairly effective. I think that answers that one question, right?
Okay. Thanks, Dr. Baxter. We are actually coming to the closure of this session. Thanks a lot, Dr. Baxter, Tamil and Ramki. Very insightful, thought-provoking discussion on generative AI and its use specific to enterprise modernization. And Dr. Baxter has actually countered GenAI with symbolic AI and other alternatives, and also how actually GenAI typically learns, and then how it actually leverages the large language model in moving forward. And thanks a lot, everyone. Over to you, Divya.
Yeah. Thank you, Padli, for moderating the session today. We see a couple of more questions and probably we'll reach out to you. So before the audience, thank you so much for joining us. And before you go, please kindly share your feedback through the survey widget. This will help us improve our future events and, of course, prioritize topics also based on your interests. So we're going to end this session with a key takeaway that I could gather is where and how do you want to use the Gen AI, and how Gen AI is more of how it would augment the process to go to near 100%, but it may not replace the legacy modernization tools. So thanks for joining us today, and I look forward to seeing you all again soon. Thank you.